Hello, in the last video I declared these as extern void. They do not need to be extern. Thank you. Alright, now that we have a memory allocate function, we need a memory free function. Freeing memory is a little bit more simple than allocating memory. Let's create a function for it now. So it'll be called void free, and we need to take a void pointer to the address of the memory that we need to free. So we need to get the memory segment header pointer of that memory block. We'll call it current memory segment, and we'll make it equal to parentheses memory segment header pointer address -1. This will return the correct address of the memory segment header of the memory segment that we're using. And we can just do current memory segment free equals true. Now we can recalculate the first free memory segment. So if current memory segment is less than first free memory segment, first free memory segment equals current memory segment. Now we need to solve the issue of the memory segment headers around this one having the wrong pointers to free headers around it. Alright, so to start off, if current memory segment next free segment does not equal null, so does not equal 0. If current memory segment next free segment previous free segment is less than the current memory segment, we can change that to current memory segment next free segment previous free segment equals current memory segment. Now if current memory segment previous free segment does not equal 0, so if it is not null, if current memory segment's previous free segment's next free segment is greater than the current memory segment, the current memory segment's previous free segment's next free segment now equals the current memory segment. Right, so that fixes the issue of the next free segments and the previous free segments. What about just the next segments and the previous segments? So let's fix that. So if current memory segment's next segment does not equal 0, the current memory segment's next segment's previous segments equals the current memory segment. And the same with the previous one. So if current memory segment's previous segment does not equal 0, current memory segment's previous segment's next segment equals the current memory segment. Alright, so that's basically everything for the free function. So this will completely free this section of memory. Now we do actually have the problem of, now this memory block has been made, we might actually get a little bit of fragmentation. So if we have a lot of small memory blocks, if we try to allocate a large block of memory, our allocator function is just going to skip over all of these small memory blocks. So to fix that, we need to combine all these free memory blocks if it is freed next to one that is already free. So to do that, we'll create a new function, CombineSegments. Void combine free segments. And this will be the memory segment header A and memory segment header B. So we'll combine A and B. Simple enough. So we need to check if either of them is null. So if A equals 0, return. Or if B equals 0, return. So now if either of them is null, we won't do anything. Alright, so we need to check if A is less than B. So if A is less than B, add B onto A. So A's memory length plus equals B's memory length plus the size of memory segment header. So basically what we're doing is we're making the length of A span the entire length of A plus the header for B and the entire length of B. Right, now we need to make it so A's next segment skips B and goes on to B's next segment. So A's next segment now equals B's next segment. Same with A's next free segment. Now needs to equal B's next free segment. Now we need to fix the headers around A and B to make sure that they point to the right segment headers. So B's next segment's previous segment now equals A. B's next segment's previous free segment now also equals A. And B's next free segment's previous free segment also now equals A. But what if B is before A? Well, we basically just reverse that. So else we can just copy all of this and replace A with B and B with A. So B, 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 A, 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 B, B, B. Alright, now that we've completed combine free segments, we need to go back to our free function and implement it inside of that. So within if current memory segment's next segment does not equal 0, after our first pointer fix, we can now do if current memory segment's next segment is free, combine free segments, current memory segment and current memory segment's next segment. And likewise with the previous segment, so if current memory segment's previous segment is free, we can now combine free segments, current memory segment's previous segment. Now we can just forward declare our free function inside heap.h, free void pointer address. Alright, now we should be able to test it. So we've allocated all of these 3 test memory addresses. We're going to print them to the screen. Now let's free test memory address. Let's free test memory address 2 and free test memory address 3. Right, now void test 4 equals malloc 0x60. Needs to be a pointer. So what this should do is create 3 dynamic memory allocations, print them to the screen, free them, create a new one, and this one should be in the first slot because we've freed all the others, combine them together, and there you go. So copy these 2 print strings here, and we can print test 4. Alright, let's see what we get. Alright, so as you can see, we've made our first 3 allocations. That's filled up all of the memory. And then we've freed it all, combined all the segments back together, and here we are. We have the new allocation right back at the first address, just as we would expect it to do. There are a couple more utility memory allocation functions that we'll make, like calloc, which will allocate the memory and then clear it, so that there's no random data in there to corrupt whatever we're putting in there. And there's also one to do memory allocation but aligned to a particular address, just in case that we need memory alignment for anything, but we'll be covering those in the next video. As always, thank you for watching, and I'll see you next time.